Stluka.
And I'm Andrew Johnson.
And our project was an analysis of a tone and volume control used in a standard guitar. What we did was we utilized a circuit that had two potentiometers. One controlled the volume of the guitar's output, and the other adjusted the tonal quality of the output. The potentiometer in series with the capacitor is what bled off higher frequencies for a tone control, and the second potentiometer that was in parallel with those two for the output. This type of circuit can be found commonly in a lot of guitars today.
So looking at the mathematical model of the circuit, it's a differential equation. And using the values that we found, so R1 is the resistance of a pickup, which is typically around 7.74 kiloohms. And the rest of the resistors are potentiometers, so you can change them. So we just set them at half the full value, so it's half tone and half volume. So R2 would be 250 kiloohms, and R3 and R4 would also be that. And then the standard capacitor used in a tone and volume control circuit is 22 nanofarads. Using MATLAB, it helped us find the transfer function. So our values that we found for the transfer function, the numerator was 5.355 times 10 to the negative 10th, and the numerator would have then been s plus 5.5148 times 10 to the negative 10th. And that's what the values plugged into it. And then using simple functions on MATLAB, we found the impulse response and graphed it. And as it's shown here, since the final value is real and not infinite, it does show that the circuit is stable.
Next, we looked at the step response through MATLAB. We were able to determine that the final value of the step response was to be 0.97, as you can see in the graph. From that, we were able to calculate the time constant, which is approximately 63% of the final value, which gave us a time constant of 0.611. Based on what we've found so far, the eigenvalue of this system is negative 5.5148 times 10 to the negative 10th. And since it is real and in the left-hand plane, the system is stable.
So using MATLAB, we then did a frequency domain analysis using the Bode function, and we plotted a Bode diagram of the magnitude and phase. And as shown on the presentation here, the Bode diagram is characteristic of a first-order low-pass filter.
Lastly, we created a Simulink model, and we introduced feedback back into the system. And when we ran it, you can see that our final value was approximately cut in half by adding the feedback.
And that's our project. Thank you.